Hello students. In the last class, we have discussed about the electricity and the various terms related to it. Today, we will discuss the classification of materials based on the phenomena that how they respond to the electric current. As we have discussed that the flow of electrons is known as the current. Now the materials which we use or which we see in our daily life, they have different type of response to that flow of electrons or to that particular current. So today we will discuss it how these are classified. These materials are basically classified into three categories. First is conductors, insulators, and semiconductors. And starting with conductors, conductors are those substances which allow the current to pass through it. Means these are the substances which make the flow of electrons easy through it. They do not oppose it. For example, we can take metals. All the metals are conductors, means there is a flow of current through them very easily. Due to this factor, all the electric wires are made up of the conductor. For example, we use copper in the house wiring. So copper is used because it is a metal, So it provides a very low resistance, means very low opposition, due to which there is a minimum loss of electric energy. Next, our class is insulator. For example, non-metals. Insulators are the substances which do not allow the flow of current through it. Means, as we discussed that conductors do not oppose, means they have low resistance. But insulators oppose the flow of current because they have the high resistance value. The opposition is too high. And all the non-metals are considered as an insulator, so they do not allow the flow of current through them. Next is semiconductor. Semiconductor, at the word semi indicates that half, means they are they behave like conductor and insulators also, means their conductivity lies between conductors and insulators. As the conductivity lies between both of them, so we state that their conductivity is temperature dependent. Means if we talk at low temperatures, then they work as a insulator. Means they do not allow the current to pass through them. But if we increase the temperature, then they behave like conductor. Means they allow the flow of electron through them. Hence, we state that conductivity lies between conductors and insulators. In this, we can take example of silicon and etc. These are the class of material which are very important nowadays to us. Now, we will discuss that we said that the flow of electrons is a current. So, that flow should follow a certain path or a definite path. That definite path or a certain path constitutes a term called electric circuit. It is defined as a path for the flow of current. Means the electric circuit, as we define, that is a path. It starts from one terminal while returns to the other. means it is a closed loop-like structure. This represents the cell. It is a ammeter. This ammeter is a device which is used to measure the current in the circuit, and it is always connected in series. Means whenever we talk of the circuit and if we want to connect the ammeter, it is always connected in series. This is voltmeter which measures the potential, and it is always connected in parallel. It is resistor. As we have discussed that the current always flow from positive to negative. So these arrows represent the flow of current, and these are known as the connecting wires. So we can see that we have started the circuit from the positive terminal of the cell, which moves about and ends up to the negative terminal of the cell. So we see that it is a closed path. Across this closed path there is a flow of current, hence it constitutes a circuit. Now there are some symbols which represents the various components of the electric circuit. Means there are some figures or there are some symbols which signifies something in the electric circuit. So now we will discuss about symbols. So our first symbol is which we have used, that is of cell, and our next symbol, if we make a group of these cells, means we combine 2 or 3 cells, then it forms a battery. So it is represented as next is our, this represents the plug key. If we draw or if we put a dot between these two brackets, then it again represents a plug key, but this dot signifies that the key is closed, while the absence of dot represents that the key is open. Means if we talk that the key is closed, it implies that the circuit is completed, while if the key is open, then it implies that the circuit is not completed, it's yet incomplete. Next is switch. Again it represents the switch, but this is closed while this is open. Again, open switch signifies that the circuit is not complete, it is yet incompleted, but closed signifies that the circuit is completed. Next, it represents the resistance. It again represents the resistance, but if we draw an arrow on these resistance, then it represents that the resistance is variable, means it varies, it's not fixed. While the above figure means the above part represents that the resistance is fixed, it is not changing. It represents the rheostat. This represents the ammeter. It is a device which is again used to measure the current, and it is always connected in series in the given circuit. It represents the voltmeter. It is a device which is used to measure the potential difference across the two ends of the wire, and it is always connected in the parallel in the given circuit. In last, this is a galvanometer which is connected in the circuit, and if it shows the deflection, then it represents that the current is flowing in the circuit. But if it doesn't show any deflection, then it represents that there is a no flow of current in the circuit. Now, while discussing the symbols, we have discussed switch is open, switch is closed, plug key is open, plug key is closed. So, on this basis, we have two types of electric circuits. One is open circuit, while other is closed. Open circuit, as the name suggests, we have discussed, means it is an incomplete circuit. If it is an incomplete circuit, means there is discontinuity in the wiring, or the circuit is not a closed loop. There is some breaking point. So whenever there is some breaking point, means there is no flow of current. Means the current is withdrawn off in between. So in the open circuit, there is no flow of current. But at the same time, if we talk of closed circuit, means the key is open, the key is closed, or we can state that the switch is closed. Means the circuit is completely enclosed. Means there is no withdrawing of current in between. So the current flows. If we want to picturize these two circuits, then this is a switch which is open in this case. So if it is open, means circuit is not completed, and if it is not completed, then this figure which represents the bulb will not glow because it is not getting the sufficient amount of current which it requires to glow. But if we talk of a closed circuit, means the key which we have used here, or the switch we have used here, is closed. Then the bulb which is present here will get a sufficient amount of current which it requires, hence it glows. So the bulb glows, and this is the closed circuit.